Welcome to Lesson 3 of Unit 8 in Module 3. We're going to now investigate some fractional exponents in this unit, in this lesson. Alright, so it says, what is the value to start this thing off of 2 to the 1/2, raised to 2 to the 1/2, and justify your answer? Well, I would hope one would plug it in the calculator and do 2 caret 0.5 or 2 caret and then parentheses 1 divided by 2, and you will get to 2 to the 1/2 is approximately 1.4142 blah 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 going on, and it is irrational. It does not end and doesn't repeat. That should give you a little bit of a clue as to how these fractions are going to relate here to our topic today. Now in the next part it says right here, go ahead and graph this function 2 to the x from -2 to +2. So I'm going to pause the video here and I'm going to give you a table. So 2 to the 0, we know anything to the 0 power. Remember, this is 2 to the x. So if I go 2 to the 0, we know that's 1. 2 to the 1 is 2. 2 squared is 4. 2 cubed is 8. And then 16. And then 32. Keep multiplying by 2. If we go the other way, we're always cutting in half. Well, what's half of 1? It's 0.5. And what's half of that? 0.25. So you will get some answers out of that we're going to investigate. But the bottom line is if I graph this thing, and this is a scale of 4 here, so I am equal to at 0 equal to 1. I'm going to pause actually the thing and put the graph in for you. If I graph it, I get those points like this, and should look familiar back to 9th grade. You got an exponential graph, which is exactly what we're doing. Raising a power to a power is exponential. Alright, now there's some things to discover out of all this, but we're going to find those out along the way. So hang on, let's roll. Okay, so on this question here, they talk about the function 2 to the x between -1/2 all the way up to 1.5. So basically from here up to 1.5 here that we're looking at. And they want you to, in the first part, to find 2 consecutive integers that are under and over estimates of this, meaning just under 2.5 and all that. Well, we already know that if I go to 2 to the 1/2, which is right here, and you actually go up, okay, the ones we're talking about that are nice ones are at 0, down here, and at 1. And those both come out to be nice things. So find 2 consecutive integers. We're looking at 0, and we are looking at 1 that are over and under. Now, does it appear that 2.5 is halfway between those integers? Well, what was the value at 0? At 0, it turned out to be equal to 1. So we had 0, 1 really was the coordinate. And at 1 turned out to be 2. So if I'm going halfway between 0 and 1 here, I would expect halfway between 1 and 2, and you would expect 1.5. Wouldn't that be what you expect? All right. Does that work, though? Use of the graph. Well, if I use the graph to estimate it, like I said, I went up, come across here. Is that exactly 1.5? No, it's somewhere about 1.4, isn't it? So it's a little bit off. It doesn't go exactly halfway in between. So then it says use the graph to estimate the value of 2 1/3. Well, if I go 2 1/3, it's a little bit over that 0.3 right here. I go up, I go across 2 1/3, and somewhere around there it's probably about 1.3 or so. Okay? Just using the graph to look at it. Let's move on. Alright, in our next examples, they're talking about the 4th root of 16. Remember, you could write 16, and it's not the square root, it's not the cube root, it's 4th root, so it has a little 4 there. If I break up 16, you guys know it's 2 times 2 is 4, times 2 is 8, times 2 is 16. And if I'm doing a 4th root, I want 4 of the same thing coming out. So that thing turns out to be the whole number 2, doesn't it? If I do the cubed root of 125, and you guys could do that on the calculator, you do it, that's 3 sets of 5. It's 5 times 5 times 5, and I need a triple to come out. So that thing turns out to be the nice number of 5. And if I do the 5th root of this thing, notice they've got 5 zeros there. So guess what? The 1 and those 5 zeros are going to come out as 1 0. So that thing turns out to do, if I do the 5th root of 100,000, it does turn out to be the number 10. So those are my answers on those questions. Now I want you to take a moment and see what you can do out of these, and then I'm going to start showing you some of the answers first. At least the first two you should be able to do. I think you can do all of them. So pause the video and give it a shot. So the fourth root of 81, you know 81 is 9 times 9, and 9's break up in 3 and 3, so I got 4 sets of 3. So if it's the fourth root, take 4 sets of the same thing out, you get 3. If I do the fifth root of 32, guess what 32 is? 5 2's. Try it, multiply them, you get that. And it's the fifth root, so I need 5 of something. So that comes out. Then the next one says, hey, I got the cubed root of 9 and the cubed root of 3. Well, guys, you can multiply those together, and you can get the cubed root of what's 9 times 3. Well, it's the cubed root of 27. Now, you could have broken that down. 9 is 3 times 3, so I get 3 3's. Or the cubed root of 27 pulls out a 3. Exactly. Okay. And the last one on D, I get the fourth root of 25, and the fourth root of 100, and the fourth root of 4. And if you put it all together, you've got the fourth root, since they're all fourth roots, of 4 times 25 is 100 times 100. So I get 100 times another 100. That means put on a pair of zeros. And there we go. I've got actually 10,000. And if you notice, nicely, I got 4 zeros there. So, and the 1's going to come out. So it's a 1 and 1 0 because I pull it out. And that's actually 10. That's how we're going to play with some of these. Alright, so here's the nuts and the bolts of it. I've got a few examples there, but I just want to take some. If I told you you got 3 squared, you know that means 3 times 3. And if I had 3 to the third power, it means I got 3 3's, right? We haven't talked about fractions yet. What if there's a denominator in that piece? Well, it turns out, in the one we did earlier, that guess what? 2 to the half power is the same thing as the square root of 2. So that 2 in the bottom tells you what root to take of the base here. And the 1, of course, is really 2 to the first power, but that's the 2 here. So we don't write the 2 right there, nor do we write the 1 right there. So that's square root. So let's apply that to this here. If I'm going to the half power, I'm really doing 3 to the first power. But then I'm going to take the denominator's a 2, so I take the square root of that. So the bottom line is, I'm not going to write the 2, I'm not going to write the 1, it's the square root of 3 is my answer. I do this one here on 11. You guys should get the idea. What do I do with 11? It goes to the first power, which is just 11, but it's the fifth root. The denominator is going to tell you the root. Now this one here, I'm going to do the fifth root of 1/4. Okay? And this one, you need to pause it, give it a shot. Okay, I get 6 in the bottom, raised to the first power, but it's going to be the 10th root of 6. And of course, none of these can be busted up in enough pairs to pull anything out. Okay, we're just rewriting them with fractional roots. Now, in the next couple of parts, we're going to rewrite these exponential things with the fractions. And if it's rational, we're going to write it there. And if it's not, we will have radicals or exponents, whatever's left here. So, if I take a look at this one, you guys get the idea. I take the top part, so it's 2 to the third power. And the bottom part, the 2, means I'm taking the square root. So that means this thing is the square root of 3 sets of 2. Is it 3 2's, isn't it? Well, when I'm taking a square root, that's a pair of buddies that comes out. So the 2 comes out. What's still under there? This 1 2 is under the radical. So that thing turns out to be 2 radical 2. Alright, so in this next one, I actually have 4 to the 5th power, and I'm taking the square root, because that's a 2 on the bottom, square root. Well, you got a couple ways of looking at that. First of all, I could take 4 to the 5th, I could put the 5 on the outside and do the 5th power, because another way you could write that is square root of 4, whole thing raised to the 5th power. It's the same thing, I'm still raising that thing to that. That would mean it's 2 to the 5th power, which is 32. Or I can write it as the square root of 4 sets of 5, so 4, 4, 4, 5 4s. So a pair comes out, so a 4 is coming out. A pair is coming out, right? So another 4 comes out. And then what's the square root of 4? It's a lonely guy left, but the square root of 4 is 2. So what's 4 times 4? 16 times 2 is? Same answer, 32. A lot of ways of doing this. Last one, you got a fraction. So you've got 1/8, of which I'm taking the cubed root, This time I'm actually going to put the 5, the power, outside. I'm going to do the other thing inside first. You can do it either way once again. So if I take the cubed root of 1, what's the cubed root of 1? It's just 1. And what's the cubed root of 8? 2 times 2 times 2. So 2 comes out. So that cubed root of 8 is actually 1/2 raised to the 5th power. Well, 1 to the 5th power, remember, you're applying, just like we did the cube root on both the 1 and the 8, the 5 also has to go on the top and the bottom. So 1 to the 5th power is 1, and 2 times 2 times 2 times 2 times 2, if I said enough times, is 32. So my answer is that fractional answer. All right, this one here says show why they're true. Well, guess what, guys? It's the proof. Get the left side equal to the right side. I'm going to draw a line down the middle here. 2 to the negative half. What does the negative sign do? Oh, yeah, it flips it. So that's 1/2 raised to the 1/2 power. It gets rid of the negative part, right? Okay, what does that mean? That means I'm taking the square root of 1/2. Okay? Well, what's the square root of 1/2? It's the square root of 1 over the square root of 2. We know the square root of 1 is equal to 1 over radical 2. We cannot leave it that way, so we multiply the top and the bottom by that radical, if you remember from previous chapters. So I will get square root of 2 over a pair of buddies is a 2. Okay? Now the right side doesn't look like that either, does it? I've got 1 over 2 to the half. So that's 1 over, well, what's 2 to the half? Square root of 2. Does that look familiar? Actually, I could stop the proof right here because it's equal to that right there. Well, in a moment here it is. Right down here, my bad. We can see it. But if we finish it off, we multiply radical 2, so that way it becomes a pair of buddies, which is square root of 2 over a pair of buddies pulls out a 2. And now, excuse me, those two are equal, and we've proven that they're the same. All right, I suggest you just pause the video here and you try these 3 and give it a little bit of a go at it. And then come back and take a look. All right, so hopefully you did that. All right, I would take care of the negative first on this one, so that means the 4 is going to get flipped, so it turns into 1/4. I am still being raised to the 3/2. Now, if you want, take the square root next on that thing. So I'm going to take the square root of 1/4. And the whole thing then is raised till the 3rd power. That takes care of the 2 in the bottom. Well, the square root of 1 on top is 1. The square root of 4 is 2. So that whole thing reduces to that inside. And I've got to the 3rd root. And now I just got to go a 3rd power, I mean. So 1 to the 3rd power is 1. And 2 times 2 times 2 is 8. There's your answer. This one here, same type of thing. I would flip first, so it's 1/27th, raised to the 2/3. This time, we're looking at that's the same thing as taking the cubed root of 1/27, because the bottom denominator is like 3, but I'm going to square it at the end. Well, the cubed root of 1 is equal to 1. Cubed root of 27 is 3, and I'm going to square it. So if I square 1, I get 1, and I square 3, I get 9. That's my answer. You can check these on the calculator, guys. You can throw them in. I can do 27 raised to the negative 2/3 power and get a decimal, and it'll come out to be like this one, 0.1111, if you change that to a decimal point, 11111, going on and on and on as a repeater. All right, and finally the last one here. I go and I want to flip it, so the flip of 1/4 is nicely a 4. You go from, so 1/4 is 4 over 1, raised to the, looks like 1/2 power. So that means 1/2 power, if you remember, I'm going to take the square root of 4, which is 2. That actually turned out to be a nice one. All right, we're going to talk more and practice more in class because some of this is newer to you. But it's not hard stuff, but you do need to know your rules. Okay? Take care. See you in class.